All right. So in the last session, we were discussing binomial theorem, but in the previous three sessions, we have done quadratic equations. So today we will take a quick look on the quadratic equation problem solvings. We'll solve certain problems which have been asked in JEE Mains, JEE Advanced, and so. So let's start. I'll give you enough time to think also. So think on the problem. So there we go. Let's start with this one. If PQ belongs to real number and 2 minus root 3 is a root of the quadratic equation, x square plus px plus q equal to 0, then which of the following is correct? Yes. If PQ belongs to real number, if 2 minus root 3 is a root of the quadratic equation, then yes. Now, if you got the answer, mark it in the poll. Mark your answer in the poll. Bombay, Calcutta. About others? Yes, yes, quickly. Now see, this is the question I'm going to solve now. Let's see whoever goes correct. So the question is, P and Q belongs to real number if 2 minus root 3 is a root of this quadratic equation. All right. So P or Q, they are real numbers. So if 2 minus root 3 is a root, it will satisfy this equation. So 2 minus root 3 whole square plus P times 2 minus root 3 plus Q equals to 0. All right. So it is 4 plus 3 minus 4 under root 3 plus 2p minus p root 3 plus q equals to 0. All right. So it will be 4 and 3, 7. So 4 plus p into under root 3 is equals to, it will be 7 plus 2p plus q. 4 and 3, 7 plus 2p plus q. This is what I got. Got it? Now, if I further square, see, because the relation you see that is in the form of integers, not having any irrational term. Got it? Or another thing what I can do, you just compare these things. So if p plus 4 goes 0, then p is what? Minus 4. Because right side is what? Not having any root. and 7 plus 2p plus q equals to 0. If you put p as minus 4, you get q as 1. So q1 p minus 4 is satisfying which option? P minus 4 q1. So minus q1 minus 16. This is satisfying option 4. P minus 4 q1, that is satisfying only option 4. Got it? All right, guys. So it was a good question. Now, try this one. Alpha and beta are the roots of this equation. Then the least value of n for which alpha. Okay, Manish saying not understand, sir. Manish, what did I do? 2 plus 2 minus root 3. See, another way I can do it. Say, let me tell you another way. If 2 plus under root 3 is a root, then 2 minus under root 3 will also be a root because irrational roots they occur in conjugate pair, isn't it? So sum of roots is what? P. So minus P is 4. So you got P as minus 4. Product of roots Q will be 4 minus 3, 1. We can also find P and Q using this method. Got it? Manish, did you get it now? Well, now you got the values of P and Q. Just satisfying whatever the options you are getting. All right. Now, let's try this question. Alpha and beta be the roots of this equation, then the least value of n for which alpha upon beta to the power n is 1. Give it a try, take 2 minutes. Give it a try, guys. I will back in a moment. Hello? Yeah, have you got it? alpha and beta are the roots of this equation, then the least value of n for which alpha upon beta whole raised to the power n is 1. Now see, if the root I talk about, that is x square minus 2x plus 2 equal to 0, its roots are alpha and beta. So alpha and beta will be minus b plus minus under root of b square minus 4ac8 upon 2. That is 1 plus minus under root of minus 4 upon minus 4. It will be under root of minus 1 because 2 I cancelled. This is it. So it is 1 plus minus iota. So roots are like alpha can be 1 plus iota, beta can be 1 minus iota. So what is alpha upon beta? Alpha upon beta is 1 plus iota upon 1 minus iota. So if you simplify it, you get 1 plus iota whole square upon 1 minus iota into 1 plus iota. So it is 1 minus 1 plus 2 iota upon 1 plus 1 2. So this is iota. So finally alpha upon beta you got as iota. So alpha upon beta raised to the power n equals to 1 means iota to the power n equals to 1. And which power of iota is 1? So n has to be what? 4 minimum. Else it can be 8, it can be 12, it can be 16 and so on so forth. Very good, Abhilash. Very good. Take a look. Got it, guys? Now, let's go with another question. Try this one. The quadratic equation x square minus 6x plus a equal to 0 and x square minus cx plus 6 equal to 0 have one common root. Other root of the first and the second root are integers in a ratio 4 is to 3. Then the common root they are asking for. Give it a try quickly. Yes, yes, everybody quick. Now, see the quadratic equation x square minus 6x plus a and x square minus cx plus 6 have a common root, the other root of the first and the second. Now, let us assume with this quadratic equation x square minus 6x plus a equals to 0. Its roots are alpha and other root I'm not taking right away. And then x square minus 6, x square minus cx plus 6 equals to 0. Roots are alpha. Now see, other roots of first and second equation are in the ratio of 4 is to 3. I assume this root is 4 beta, then this root will be 3 beta. So one common root I took as alpha alpha, and uncommon root, one root I took as 4 beta, other as 3 beta, so that their ratio is 4 is to 3. Now from this, you get alpha plus 4 beta as 6 and 4 alpha beta is A. Now from this, alpha plus 3 beta is C and 3 alpha beta is 6. If I divide these two, I get 4 by 3 is A by 6. From this, you got A as 8. Am I correct? A as 8. So if you put A is here, so x square minus 6x plus 8 equals to 0. इसको if you factorize x minus 2, x minus 4 equal to 0, you get x as 2 and 4. Got it? So roots are 2 and 4. So I think 2 will be the common root. So if I place 2 here and 4 means beta is 1. So we get the value of C. They're asking for the uncommon root. Now uncommon root can be 2, can be 4. That is what we have to decide now. So like if I take alpha, common root as 2. If I take alpha as 2, so beta will be 1. So that means it is sorted. Its roots will be 4, its root will be 3. Beta 1, so root will be 3. And here root will be 4. Got it? So very good, Abhay. So the common root is 2. Your answer is 2. Okay, let's take another call. What if common root is 4? And just as a cross check, if I take alpha common root as 4, then beta will be 1 by 2. Got it? So this equation itself is not satisfying. This equation is satisfying. Alpha 4 beta 1 by 2. So 4, 3 to just 6. Alpha 4 beta 1 by 2. If I take it here, alpha 4 beta 1 by 2. Beta 1 by 2. Then C will be 4 plus 3 by 2. 11 by 2. So it is x square minus 11 by 2 into x plus 6 equal to 0. And 1 is not a root of this equation. So this situation does not satisfy. You got 4. Got it? Now, try this question. Very good question. This came in JEE Mains 2015. This question also came in JEE Advanced once. Alpha, beta are the roots of this equation. An is alpha to the power n minus beta to the power n. Value of A10 minus twice of A8 upon twice of A9. Yes. Yes. Alpha and beta are the roots of this quadratic equation. See, enough time I have given to you. The equation x square minus 6x minus 2 equals to 0. Its roots are alpha and beta. So alpha plus beta goes 6. Alpha beta is minus 2. Am I correct? Now they are asking for A10 minus twice of A8 upon A9. A10 is what? Alpha to the power 10 minus beta to the power 10 minus 2 times. 2 times it will become plus alpha beta I replace. A8 is alpha to the power 8 minus beta to the power 8 upon twice of alpha to the power 9 minus beta to the power 9. Am I correct? So it is alpha to the power 10 minus beta to the power 10 plus alpha to the power 9 beta minus alpha beta to the power 9 upon twice of alpha to the power 9 minus beta to the power 9. So alpha to the power 9 common, you got alpha minus beta from these two terms, alpha to the power 9 common. From the remaining two terms, beta to the power 9 common, you get again alpha minus beta upon twice of alpha to the power 9 minus beta to the power 9. Got it? Now from this, if I take alpha minus beta common, sorry. If I take alpha to the power 9 common, I get alpha plus beta here also. So alpha plus beta, alpha to the power 9 minus beta to the power 9 upon twice of alpha to the power 9 minus beta to the power 9. They both cancelled. So it is alpha plus beta upon 2. Alpha plus beta is what? 6 by 2. It will be 3. Tell me, how is it? Got it? Now, go with this question. If one root of this equation is square of the other, then solve it quickly. See, as many questions you will solve, it will be that much beneficial for you. Myself solving question won't give you any benefit. So you just run behind the question, you solve it. Try to give your best efforts to solve this question. Yes, quickly try. Option D. Abhinash is saying, okay, I'll start the poll for you. Give me your opinion. Yes. All right. Others also try. Now see, let me do it. Let's see the answer is. They are saying one root of this equation is square of the other root. So x square plus px plus q equals to 0. They are saying if one root is alpha, other root is alpha square. So I got alpha plus alpha square as minus p and alpha cube as q. Am I correct? So in this equation, cube both sides. So what did you get? Alpha cube plus alpha to the power 6 plus 3 alpha cube into alpha plus alpha square is equals to minus of p cube. Correct? So alpha cube is what? Q plus alpha to the power 6 q square plus 3 alpha cube. Alpha cube is what? Q into alpha plus alpha square is minus p cube. So your answer is p cube plus q square plus q into 1 minus 3p is 0. P cube plus q square plus q into 1 minus 3p equals to 0. Very good. Avinash. Very good. Got it, everybody? Am I correct? Now, let's go. Go with this question. J means 2020. If lambda not equal to 0 be a real number, alpha, beta are the roots of this equation, alpha, gamma are the roots of this equation, then beta, gamma by lambda is equal to, they're asking for. Quickly. Unknown caller. Yes, quickly. Yes, quickly. See, lambda not equal to 0 be real number, alpha, beta are the roots of this equation. So there is the equation x square minus x plus 2 lambda equals to 0 with roots as alpha, beta. And now there is another equation 3x square minus 10x plus 27 lambda equal to 0 with roots as alpha, gamma. Got it? Now, one thing I do see here that alpha is a common root. If alpha is a common root, it will satisfy both the equations. So alpha square minus alpha plus 2 lambda equal to 0. Another equation is 3 alpha square minus 10 alpha plus 27 lambda is equals to 0. Multiply first equation by 3, you get 3 alpha square minus 3 alpha plus 6 lambda equal to 0. Now you subtract both of them. So I get minus 7 alpha plus 21 lambda equals to 0. So alpha is what? 3 lambda. Now alpha is 3 lambda. It will satisfy first equation. I put the value in the first equation. So I get 9 lambda square minus 3 lambda plus 2 lambda equals to 0. So it is 9 lambda square minus lambda equals to 0. So either lambda is 0 or lambda is 1 by 9. Got it? Now, if lambda is 0, x square minus x equals to 0. So one root is 0, one root is 1. If lambda 0 I place in the second equation, I get 3x square minus 10x equal to 0. So one root is 0, other root is 10 by 3. Now the question saying, okay, in the question there is still saying lambda is non-zero. So lambda is non-zero means there is no point of discussing this option. Got it? So that means lambda is what? 1 upon 9. So lambda is 1 by 9. That means alpha beta product of roots here is 2 lambda. I will solve the equations. So it is x square minus x plus 2 by 9 equal to 0. So 9x square minus 9x plus 2 equal to 0. So we can calculate both the roots here. Now another equation is 3x square minus 10x plus 3 equal to 0. From there roots will be 3 comma 1 by 3. From this equation roots will be, if I solve it, 18. 18 means 6. So it will be 9x square minus 6x minus 3x plus 2 equal to 0. So x will be, one root is 3x, one root is 1 and other root is 2 by 3. How is that possible? Alpha beta and alpha gamma. One root should be common in both the equations. Alpha came 1 by 9. So 9x square minus 9x plus 2. 9x square minus 9x. 1 by 9 alpha came plus 2 equals to 0. 6 and 3 minus 3x, 2 by 3 and one root is, okay, other root is 1 by 3, 1 by 3 and 2 by 3. So 1 by 3 is the common root. So basically beta came 1 by 3 and gamma came 3. Now they are asking for beta gamma upon lambda. So 1 upon 1 by 9, answer is 9. Am I correct? Have a look. Got it? Now, go with this question. The integer k for which this inequality is valid for every x in R. Quickly try. Mark your opinion in the poll. Yes. Well, let me do it. Question is the integer k for which this inequality is valid for every x. So, if for every x it is valid, that means graph of this is like this. Got it? Means its d should be less than 0. So 4 times of 3k minus 1 ka whole square minus 4a is 1, c is 8k square minus 7. It should be less than 0. 4 cancel. 9k square minus 6k plus 1 minus of 8k square minus 7. It should be less than 0. So it gives k square minus 6k plus 8 less than 0. So it will be k minus 2 into k minus 4 less than 0. So k lies between 2 to 4. K lies between 2 to 4. So between 2 to 4 is valid for every x. There is only one integer existing, the integer k. Okay, k they are asking, so that is 3. Integral value of k we have is 3. Between 2 to 4, one integer, that is k equals to 3. Am I correct? So this is simple treat. Now go with this one. If both roots of the quadratic equation are less than 5, then k lies in the interval. Yes, quickly. So both roots of this quadratic equation are less than 5. Means the case is like this. This is 5 and both roots are less than 5. Am I correct? So what we have to do? First of all, d more than equal to 0. First thing. Now average of roots alpha plus beta by 2. It should be less than 5. And last case I have told you, if this is fx as x square minus 2kx plus k square plus k minus 5, then f of 5 should be greater than 0. You see that? F of 5 should be greater than 0. So if we apply all these three cases, you will be like able to answer it. Got it? Well, this is all for the day. I think we have given a good insight to these questions. Now, I would like from all of you a small feedback about the session.